Okay. Today I want to talk about section 6.8, indeterminate forms, L'Hopital's rule, and relative rates of growth. This is outline. So let me see. We think about 4 kinds of limit problems. The first one, limit f of x over g of x value approaches a. Second one, limit of f of x times g of x as x approaches a. Limit f of x minus g of x as x value approaches a. Limit f of x to the g of x value approaches a. We think about these 4 kind of limit problems. So next, what are indeterminate form from the 4 limit problems? So we think about indeterminate quotient form from here. We think about the first one. The indeterminate product form from here. Indeterminate difference form, we think about third one. Last one, indeterminate power form, we think about this one. How can you find the limit of an indeterminate form? So we have 3 methods. The first one, algebraic method. Second one, L'Hopital's rule. Third one, relative rate of growth. So we think about the 3 kind of methods. This is a whole outlines in section the 6.8. The first one, indeterminate quotient form. So we think about type 0, 0, infinity over infinity form. Type 0 of 0. The limit x of x, what's that? You plug 0 into here. So exactly 0 of 0 form. Could you turn off your audio, please? Yeah, thank you. Yeah, here, the 0 of 0 form is right. So how can you solve? You can cross out x. So this is same to the limit x value approaches 0 from the right, just 1 over 1 is 1. What is limit of 1? So could you run your answer on the chatting board, please? What's the limit of 1? Yep. So what do you think, other guys? This answer is right, the 1? Yes, thanks. Yes, this is 1. Here, the limit exists. Another type 0 of 0, like this. You plug 0 into x. So what happens? Exactly the 0 over 0 form. 0 over 0 form. How can you calculate? Cross out 1x like this. So you can draw the graph. The graph of 1 over x is like this. X value approaches 0 from the right. So 1 over x is going up, so going to the positive infinity. The infinity is not a finite number. Answer is like this. Limit does not exist. We think about type infinity over infinity form. The same. You can plug infinity into top one and bottom one. Exactly infinity over infinity form. How can you solve? Same. Cross out x like this. The limit is 1. Exists. Another type infinity over infinity form. Limit x squared over x. You plug infinity into top and bottom ones. So we have same type. How can you solve? Cross out x. We have it. You plug infinity into x. Answer is infinity. Limit does not exist. So what's that? We have like the same type 0 over 0 form. 0 over 0 form. Sometimes limit exists. Sometimes limit does not exist. is called on indeterminate form of type 0 of 0 or infinity over infinity, like this. The next one, how to find the limit of an indeterminate quotient form. This is like one example. You plug one into top one and bottom one. So what's that? The 1 square minus 1 over the 2 times 1 square minus 1 minus 1. Top one is 0. Bottom one is 2 minus 2 is 0. So we have 0 of 0 form. How can you solve? So do you know how can you solve this problem? So how can you solve? Yes, factor. So x squared minus 1 is x minus 1 times x plus 1. 2x squared minus x minus 1 is x minus 1 times 2x plus 1. Here, this is negative 2x. This is x. You add the minus x. Yes, so we have it, right? So we have like this. Next, cross out x minus 1. So we have it. The last step is you plug 1 into x. Exactly 1 plus 1 over 2 times 1 plus 1. Answer is 2/3. Here, how can you solve this problem? We can use another algebraic method. You can plug infinity into top one and bottom one. So this is exactly infinity over infinity. Well, how can you solve this problem? You can multiply top and bottom by highest power term in the denominator, x squared. This is like idea, so like this. The next, distribute 1 over x squared. Distribute 1 over x squared. So x squared times 1 over x squared is 1. 1 times 1 over x squared is minus 1 over x squared. Same. You can distribute the 1 over x squared to each term. 2x squared times 1 over x squared is only 2. The negative x times 1 over x squared is only x is crossed out. The minus 1 over x. The minus 1 times 1 over x squared is minus 1 over x squared. So we have it. The next, x value approaching infinity, so what happens? 1 over x squared is going to 0. 1 over x is going to 0. 1 over x squared is going to 0. So remaining thing is 1 over 2. Answer is like this. We can use algebraic method for solving these problems. Another one. Could you use algebraic method? This is 1 into top one and bottom one. So what happens? The adding up 1 over 1 minus 1. Do you remember? What's adding up 1? Adding up 1 is, yep, thanks. 0, bottom one is 0. We have a 0 over 0 form. So in this case, it is difficult to find the limit by using algebraic method. Limit ln of x over x minus 1, you plug infinity into top and the bottom one. So ln of infinity is infinity. Bottom one is infinity minus 1 is infinity. Infinity over infinity. So same. It is difficult to find the limit by using algebraic method. How to find the limit of indeterminate form of type 0 over 0 or infinity over infinity? We can use L'Hopital's rule, just like main topic in section 6.8. What is L'Hopital's rule? Here, suppose function f and function g are differentiable n. G prime of x is not equal to 0 on open interval I that contains a except possibly at a. Suppose that limit of f of x as x value approaches a equal to 0 and limit of g of x as x value approaches a equal to 0. Or limit of f of x as x value approaches a is plus or minus infinity, positive infinity or negative infinity. Limit of g of x as x value approaches a is same, positive infinity, 1 negative infinity. So what does it mean? So we think about limit of the f of x over g of x things, x value approaches some a. So we can use this one. You plug top and the bottom on, we have 0 over 0 form. You can plug this one and this one into top and the bottom on, we have infinity over infinity form. This infinity includes plus and minus. This infinity includes plus and minus. So plus and minus. How can you solve limit of f of x over g of x? We can use this idea. Limit of f prime of x over g prime of x as x value approaches a. This is the idea for finding limit values. So the limit on the right side exists or is infinity or negative infinity. Note, x approaches a, this one, x value approaches a, you can replace by any of the symbols. X value approaches only a from the right, x value approaches a from the left, approaches positive infinity, 1 negative infinity. We always use this rule. So when do you use this rule? Just 0 over 0 or infinity over infinity, you can use L'Hopital's rule. Sorry. Yeah, this is like L'Hopital's rule. We're going to think about previous examples. So first one. So this is a plug 1 into top one and bottom one. This is exactly ln of 1 over 1 minus 1 is 0 over 0 form. Exactly 0 over 0 form. I want to use L'Hopital's rule. So take a derivative top one and bottom one. What is ln of x prime? What's that? Do you remember ln of x prime? Do you know? Could you run your answer on chatting board? So what do you think? Is it right? Oh, thanks a lot, guys. The 1 over x, x minus 1 prime is 1. This is the same to limit of 1 over x. You plug 1 into x, the 1 over 1, answer is 1. Second one, you can plug infinity into top and the bottom one, exactly infinity over infinity. So we have infinity over infinity. So we can use L'Hopital's rule again. Same. 1 over x over 1, 1 over x. You plug infinity into bottom one, answer is 0. Okay, this is the whole idea for solving this kind of problem. You can apply more problems here. You can plug 0 into top one and bottom one. So what happens? So we have, so this one is the tangent of 0 minus 0 over 0 cube. Do you know what is tangent of 0? What's tangent of 0? Do you know tangent of 0? Is it right? Is it right? Yeah, thanks. 0 minus 0 over 0 is exactly 0 over 0. So we can use L'Hopital's rule. What's it like tangent prime? Tangent prime is, yes, is it right? Secant square? What do you think, other guys? Is it right? It's good. Secant square of x, so x prime is 1 minus 1. Bottom one, x cube prime is 3x squared. So we have like this. You plug 0 into top one and bottom one again. Was it like secant square of 0? Secant square of 0 is, I can change identity, cosine square of 0. What's cosine of 0? Is 1? Is it right? Is it right? 1? Cosine 0 is 1? Yes. This is 1. So what's that? This is going to 1 minus 1 over. You can plug 0 into bottom one. 3 times 0 is 3 times 0 square. Exactly 0 over 0. What's that? We have this type, use L'Hopital's rule again. Okay. Was it like secant square of x prime? The secant, the square of x prime is, you can use power rule. 2 is like power is down, 2 times secant x times inner function secant x prime. So we have 2 times secant x times. Secant prime is secant x times tan x. We have this result. So 3x square prime is only 6x. So we have it like this. The next ion split. You plug 0 into here. What's that? Secant of 0 is 1. This is 1. Tangent of 0 is 0. So you plug 0 into x, this is 0. You can just split non-zero part and zero part. This is non-zero part is 2 secant square of x. You can combine this one. 2 secant square of x over non-zero part is 6. The zero part is tangent of x over x. So next, distribute limit to the first and the second one. This is a limit. X value approaches 0. Limit. X value approaches 0. You can split non-zero part and zero part. Was it like a non-zero part? You plug 0 into here. As I said before, secant of 0 is 1. 2 times 1 square is 2. 2 over 6. We have 2 over 6. Limit. X value approaches 0. So tangent x over x is right. So we have this result. So what's that? Now like this is 1/3 limit. X value approaches 0. Tangent of x over x. You plug 0 into top one and bottom one again. So what's that? Tangent of 0 over 0 is 0 over 0. We have 0 over 0 form. You can use L'Hopital's rule again. So we have it. So tangent prime is secant square. X prime is 1. Just 1/3 limit. Secant square of x over 1. The same. You plug 0 into x. Secant of 0 is 1. The 1 square equals 1. So we have this one. The 1/3 times 1 is 1/3. This is the whole idea for solving this problem. So far so good? It's good? Okay. The next tip. Find limit. Sine of x over 1 minus cosine of x. So I want to use L'Hopital's rule. Sine x prime over 1 minus cosine x prime. What is sine prime? Sine prime is, do you remember? Yes, we have, cosine of x. Here, 1 prime 0, cosine prime is negative sine. The negative 1 times the negative sine is sine of x. So we have it. You can plug pi into top one and bottom one. So we have the cosine of pi over sine of pi. Remember, what's the cosine of pi? Do you know cosine of pi? 1 or minus 1? The minus 1, 1. What do you think? The minus 1? Yep. You can just sketch the graph cosine function. The cosine function is starting point is 1, going down and up like this. So this is like pi. So we have negative 1. This is minus 1 over. What is sine of pi? Sine of pi is, do you know sine of pi? This is cosine of x. Yeah, this is 0. Going up, down, up like this. This is pi. This is sine of x. Sine of pi is 0. Minus 1 over 0, one side limit, the undefined. Is right? Limit value is undefined, does not exist. So we have two possible answers in this case, non-zero zero form, the infinity or negative infinity. We have two possible answers. How can decide? Cosine of pi is like negative, very clear. Second one, was it like a sine function as x value approaches pi from the left? I'm going to use graph. X value approaches pi from the left. Sine function is above x-axis, like positive. Negative over positive. Answer is negative infinity. So like this. Is right? This calculation is right or wrong? This calculation is right or wrong? What do you think? It's good? It's right? It's right or wrong? So what do you think? It's right? This calculation is right? This is answer is mass infinity? It's true? It's right? What do you think? It's right? It's right? It's right? It's right? This is wrong. Because why? X value approach pi from the left. Before use L'Hopital's rule, you can check. When do you use L'Hopital's rule? Just of zero of zero form or infinity of infinity form, you can use L'Hopital's rule. So you can plug pi into here. Exactly sine of pi over 1 minus cosine of pi. What's that? Sine of pi is 0. 1 minus cosine of pi is minus 1. We have 0 over 2. 0 over 2 is not 0 over 0 form, not infinity over infinity form. What does it mean? Don't use L'Hopital's rule. So this is wrong. This is wrong. What is the answer? Answer is 0 over 2 is just what? 0. Answer is 0. Really be careful. When do you use L'Hopital's rule? Just 0 over 0 form or infinity over infinity form, you can use L'Hopital's rule. Other cases, don't use L'Hopital's rule. This is the idea. So this is very important. Here, like this. It's good. Next one. This question. So we have one special case. X value approach infinity. You plug infinity into f of x and the g of x. We have infinity over infinity form. X value approach infinity. We have infinity over infinity form. So how can you find this kind of things? Yes, we can use L'Hopital's rule. But sometimes the L'Hopital's rule is very complicated. One example is limit x value approach infinity. So we have ln of x to the power 1000 over here ln of x to the power 10,000 plus 5 to the x. So this is exactly infinity over infinity form. So how can you solve this problem? Yes, we can use L'Hopital's rule, but you have to use L'Hopital's rule 10,000 times. You can spend long time for solving this problem. So how can you solve this problem very quickly? I want to use another method that we call relative ratio growth. Relative ratio growth. Or L'Hopital's rule. This is sometimes you can spend a long time. Definition. The f of x grows faster than g of x. What's the definition? As x value approaches infinity, limit of f of x over g of x, x value approaches infinity equal to infinity. Or g of x over f of x as x value approaches infinity equal to 0. So this is makes sense. Now I want to give one example. The f of x equals like x squared the g of x equals like just x. So what's that? F of x is x squared is like parabola going up. This is function f. G of x is like linear function here. So x value approaches infinity. So what happens? The f of x is going to infinity faster than g of x. F of x is going to infinity very fast. So what happens? Limit of x value approach infinity, we can calculate f of x over g of x. So exactly x is square of x is crossed out, just limit x value approach infinity, just x. Answer is infinity. So like this, so we have it. The top one is growing faster than bottom one, always infinity. The limit x value approaches infinity, g of x of f of x is x over x squared, x is crossed out, we have limit x value approaches infinity, 1 over x. Answer is 0. So true, right? This is the one definition that makes sense. Note, we also say that the g of x grows slower than f of x, the f as x approaches infinity. We'll denote this by this notation. The f of x is growing faster than g of x. So another definition, f of x and g of x grow at the same rate as x value approaches infinity. What's that? Limit of f of x over g of x equals some number m. M is non-zero and finite number. Non-zero and finite number. So like this. So this makes sense? I'm going to give one more example. F of x equals 2x. So g of x equals like x. What's it like a graph? Graph is like this. This is f. This is g. So we can calculate limit x value approaches infinity. F of x over g of x is 2x of x. X is crossed out, only 2. We have non-zero finite number. What does it mean? The f of x, g of x grow at the same rate. So this makes sense? This makes sense. X value is here. You can calculate. So this length is same to this length. What's like ratio? 1 to 2. You can choose this point, draw same length. Ratio is 1 to 2. The relatively same rate. It's like same rate. Relatively same rate, always 1 to 2. So this is definition. Note, we'll denote this by like a bridge. So f of x and g of x grow at the same rate. We can use this notation. Here, so which is growing faster? So in this case, exactly x value approach infinity, infinity over infinity form. I want to use L'Hopital's rule. So what's like ln of x prime? ln of x prime is 1 over x. ln of x prime is 1 ln of x prime over ln of x. Is right? So we have the like this. So ln of x prime is, this is 1 over x over ln of x, the same to 1 over x times reciprocal of denominator ln of x. So we have 1 over x times ln of x. So we have it. Next, simplify. This is limit x value approach infinity. Numerator is 1 over x times the reciprocal of denominator x times ln of x over x. 1. X times ln of x over 1. X is crossed out. Just limit x value approaches infinity. Just ln of x. So x value approaches infinity. Ln of infinity is infinity. So like this. What's that? Top one is growing faster than bottom one. So we have it, this infinity. Top one is growing faster than bottom one. So one more. Limit x value approaches infinity, ln of x, same. X value approaches infinity, you plug into top one and bottom one, so we have infinity over infinity. You can use L'Hopital's rule. ln of x prime over x prime, the same result. The 1 of x over 1, this is just 1 of x, answer is 0. So what does it mean? The bottom one is growing faster than top one. So like this. Here, ln of limit x squared of e to the x, plug infinity into top one and bottom one, exactly infinity over infinity. You can use L'Hopital's rule. The x squared prime is 2x. E to the x prime is e to the x. So you can use L'Hopital's rule again because infinity over infinity form. The 2x prime is 2, e to the x prime is e to the x. You plug infinity into here, 2 over infinity is 0. So what does it mean? The bottom one is growing faster than top one, right? So we can use this kind of method. We have one good table. Just like the chain below lists some common functions according to their rate of growth as x value approaches infinity. So we have this one. What's that? ln of x to the power beta is growing faster than ln of x to the power alpha. What's it like alpha and beta? Alpha is positive, beta is positive. So what does it mean? So like this one. ln of x to the power 0.01. This is not 0.01. So like this one, 1,000. Here, this one is 1,000. The ln of x to the power 0.001. So which one is growing faster? This is always growing faster. It doesn't matter. Any power, right? This is like exact meaning. So, oh, it's just similar. X to the power p, x to the power q, what's that? The x to the power p is growing faster than any ln function. So x to the q is growing faster than x to the p. So we have this notation, these values. The p is greater than 0. The q is greater than p. So one more, x to the power q, like exponential function. Exponential function is the growing faster than any algebraic function. One example is x to the 1 million. This is 1.12 power x. So exponential function is always growing faster. One important thing is that a is what? Greater than 1. So b to the x is growing faster than a to the x. We have this inequality. The b is greater than a. The last one, x to the x is growing faster than b to the x. So this is the whole chain. So you need to memorize this chain. This is very useful. So like this, the one example. Let me see. How can you solve this problem? You can use this chain. So you have to ignore coefficient here. One important thing is that x value approaches infinity. Top one is going to infinity, bottom is going to infinity. You can use this chain. ln of x to the 100 is here. ln of x to the power 100 is here. One more, ln of x. ln of x is ln of x to the power 1. This one is growing faster. So you can choose fastest one from the top one. Ignore constant, ignore slow one. The next is the root x plus 1. So ignore constant one, only root x. So what happens? We have top one has ln of x, bottom one has root x. So we have only this one. So root x is x to 1/2. So we have ln of x is here, 1/2. X to the 1/2 is here. So which is growing faster? X to 1/2 is growing faster than ln function. So bottom one is growing faster than top one. Answer is 0. This is the whole idea. So let me see. What do you think? You can think about it. What is the answer? So by using this chain. So what do you think? What is the answer? Could you write your answer on the chatting board for this problem? What do you think? You can use chain. What is your answer? You think about it. What is the answer? Do you have any idea for solving this problem? So I can help a little bit here. This is a power 2x is not good. You can change it. This whole thing is exactly same too. The 4 square to the power x. This is 16 to the power x. You can change. The next here we can compare 9x, 16x, 10. Ignore constant. So which one is growing faster? 9 to the x or 16 to the x? So which one is growing faster? So which one? Yes, here. 9 to the x, 16 to the x. The 9 and 16 is greater than 8. Yes. So we have it. You have to ignore this one. What's the bottom one? 10 to x, x to the 1000, ln of x is 20. So which one is growing faster? So which one is growing faster? Yes, 10 to x here. X to the 1000 here. 10 to the x is here, growing faster. The ln of x to the 20 is here. ln of x to the power 20. So this is fastest one. You have to ignore slow one. Limit is not 1. You think about it here. 16x and 10x. You can choose this one. So what happens? The 16 and 10x. So 16 to the power x, 10 to the power x. 16 to the power x is growing faster than 10 to the x. Answer is infinity. Is right? Not the same rate. Does it make sense? Oh, yeah. Good. Here, what do you think? What is the answer? What is the answer this question? The limit ln of x to the 5 plus 1 over ln of x. What is your answer? So what do you think? What is the answer? So which one is growing faster? Top one or bottom one? What do you think? Answer is infinity. Top one is growing faster. Is right? Top one is growing faster. Top one. Really be careful. So we cannot compare ln of x to the 5 and the ln x because we have only ln x. So we don't have ln of x to 5. So we don't have it. Is right? So what's like the best way? So only think about x of 5 plus 1, ignore constant 1. So we have it. 5 is like down, like this. ln x is crossed out. Answer is 5. What does it mean? At the same rate. At the same rate. So this is the one idea for solving this problem. Okay, next tip. We think about indeterminate product. Limit of f of x times g of x. We think about it here. How can you solve? Cross out 1. Limit exists. This is type 0 infinity, right? X value approach infinity. The 1 over x approach to 0. X value approach to infinity. Exactly 0 times infinity form. The second one, how can you do that? Cross out x. Only x. Answer is infinity. Limit does not exist. So what kind of form? 1 over x is going to 0. X squared is going to infinity. We have 0 times infinity form. For same type, different answer. Sometimes it exists, sometimes it does not exist. So like this. So the limit may or may not exist in type 0 times infinity is called an indeterminate form of type 0 times infinity. So we don't have more indeterminate form. The infinity times infinity is just infinity. The always does not exist, not indeterminate form, only 0 times infinity. 0 times infinity is indeterminate form. Here, how to find limit f of x times g of x as infinity form of type 0 times infinity. Here, one idea is the next one. You can, the f of x is going to numerator, g of x is going to denominator by using reciprocal. What's that? This is 0 times infinity form. Top one is 0. Was it like 1 over infinity? 1 over infinity is 0. Exactly 0 over 0. How can you solve? You have to use L'Hopital rule. This is the idea. You can change it to the 0 over 0 form. You can take derivative like L'Hopital rule. The another method is the g of x is going to numerator, f of x is going to denominator by using reciprocal. What happens? This is 0 times infinity form. The g of x is infinity. The f of x is like 0. What is 1 over 0? 1 over 0 form is 2 possible answers plus or minus infinity. What's that? Exactly infinity over infinity form. You can use L'Hopital rule. This is the idea. So this is the idea. We have product 1. How can you find the limit? You can change it to the quotient form. The next, you can use L'Hopital rule. This is the whole idea. Here, 2 possibilities. The first one, x value approaches 0. You plug 0 into here. What is ln of 0? ln of 0 is going to minus infinity. Exactly 0 times infinity form, indeterminate form. We have 2 possibilities. First one, x is numerator. ln of x is going to denominator. So we have it like this. Second case is ln of x is numerator. X is denominator. So we think about which one is better. You can try both of them and check which one is the better. This is L'Hopital rule. So you can calculate the denominator, 1 over ln of x prime. How can you calculate? So I want to change it to the power form. ln of x to the power minus 1 prime. You can use chain rule and the power rule. The minus 1 is down, ln of x to the minus 2 times inner function, ln of x prime. You can change it to the quotient form. The minus 1 times ln of x to the minus 2 is 1 over the ln of x to the power 2 times ln of x prime is just 1 of x. So we have it like this. So you plug this value into here. Plug into here. So we have this result. You can use reciprocal. The minus x times ln of x squared is right. The what happens? Original one has only x times ln x, but resulting thing is x times ln of x squared. Power is increasing. What's that? More complicated. So this choice is not good. I can use this one. Same, use L'Hopital's rule. The ln of x prime is 1 over x. What is 1 over x prime? Could you run your answer? What is 1 over x prime? Do you know 1 over x prime? So what is 1 over x prime? Yep. 1 over x prime is, you can use change the power prime. You can use power minus 1 times x to the negative 2. So we have minus 1 over x squared. We have this result. Yes, we have it. And limit x value approaches 0 from the right. 1 over x times reciprocal of denominator. X square of minus 1. X is crossed out. Just limit. X value approaches 0 from the right. This is just x over minus 1 is negative x. You can plug 0 into x. The minus 0 is 0. This is like a whole idea for solving this problem. But let me see. We have ln function and polynomial or algebraic function. How can change it? This is better. ln of x is top. The algebraic function is going to denominator by using reciprocal. This is better. This is better. We know this kind of things. So next one is indeterminate difference. F of x minus g of x. We think about this problem. The limit of x minus x, the x minus x is 0. Just limit of 0. What's the limit of 0? The 0. So like this. Limit exists. So you can plug infinity into x and x exactly infinity minus infinity form. Is right. Second one, how can you solve this one? What is the answer? What do you think? What's the limit? X squared minus x. What is the answer? Answer is infinity. Yep. You can factor out x. The x value approaches infinity. X minus 1 approaches infinity. Infinity times infinity is infinity. Limit does not exist. Same. You plug infinity into x. What's that? Infinity minus infinity. So what does it mean? The limit may or may not exist in type infinity minus infinity. And is called on indeterminate form of type infinity minus infinity. How to find limit f of x minus g of x as x value approaches a on indeterminate form of type infinity minus infinity? Try to convert the quotient into a quotient, the difference into a quotient. For instance, by using a common denominator or rationalization or factoring out a common factor so that we have an indeterminate form of type 0 over 0 and infinity over infinity. So you can use L'Hopital's rule. This is the whole idea. This equation. So this case is exactly infinity minus infinity form. You can use a graph. This is very clear. How can you solve? You can change it to the quotient form. So do you know identity of secant? What is identity of secant function? Do you know identity of secant? Do you know identity of secant function? Yes, 1 over cosine. What is the identity of tangent? What is identity of tangent? What's identity of tangent? Yes, sine of cosine. You can change it to the fraction and combine. So what happens? You plug pi over 2 into here. 1 minus sine pi over 2 is 1 minus 1. cosine pi over 2 is 0. Exactly 0 over 0. You have to use L'Hopital's rule. The 1 prime is 0. Sine prime is cosine. Cosine prime is negative sine. You can change it positive. This is same to what? Limit. X value approach is pi over 2 from the left. Just cosine x over sine x. You can draw the graph is better. Cosine graph is like this, cosine. The sine graph is like this. We have pi over 2. This is pi over 2. This is pi over 2. Y value is 1. You can plug pi over 2 into cosine and sine. What's that? Cosine pi over 2 is 0. Sine pi over 2 is 1. Final answer is 0. So that's it. This is the idea. The next thing, indeterminate power form. The f of x to the g of x, how can you decide the power form? So idea is like this one. The knot is to figure out the indeterminate form from f of x to the power g of x. So idea is like this one. F of x to the power g of x, you can take ln. G of x is down, g of x times ln of f of x. You can change it. So you can change the product, very easy to figure out indeterminate form. We have only one indeterminate form of power things, just 0 times infinity or infinity times 0. We have this kind of thing. This is the idea. So take ln, the g of x times ln of f of x. What is f of x? What's it like g of x? You can figure out these things. First one, infinity times 0. The g of x is infinity. It's good. The ln of f of x is 0. What is f of x? What's f of x? What does it mean? Ln of f of x is going to 0. What is f of x? What's that? What do you think? Yes, 1. You can draw graph of ln function. This is ln function here. Yes, inside 1, the ln of 1 equals always 0. Inside is 1. So we have fx is 1. So we have this result. Second case is 0 times minus infinity. So g of x is 0. So ln of f of x is going to minus infinity. What is f of x? F of x going to some number? Yes. 0. ln function is going to minus infinity. So f of x is 0. We can draw the graph again. This is ln function. ln of f of x is going to negative infinity. Inside an approach to the 0. So we have 0. The last one, 0 times infinity. ln of f of x is going to infinity. What happens? F of x. What's that? The ln of f of x is going to infinity. What happens inside on f of x? You can draw graph. Yes. This is ln function. ln graph is going to positive infinity. Inside the part approach is also positive infinity. F of x is going to positive infinity. F of x is going to positive infinity. G of x is 0. We have infinity and 0. So we have it. So what kind of type? You can plug into here. So we have the 3 kinds of indeterminate power forms. Here, f of x is 1. G of x is infinity. You plug into here. So we have 1 to power infinity form, indeterminate form. Another one, f of x is 0, g of x is 0. Plug into base and the power. We have 0 to the 0 form. Another one, f of x is infinity, g of x is 0. You plug into base and power. We have last one is infinity to the 0 form. We have 3 types of indeterminate power forms. So like this. We have 3 types. 1 to infinity, 0 to 0, infinity to 0. We have 3 types of indeterminate form. How can we solve? So we can use this idea. Step 1. Take the natural logarithm on f of x, g of x here. Take ln f of x to g of x is down, g of x times ln of f of x. Next, step 2. Take the limit as x value approaches a. Take limit on both sides here. Take limit on both sides and calculate. How can you calculate? So in this case, the previous result, what's that? So we can change this form always infinity times 0 or 0 times infinity form. So how can you solve? The indeterminate form 0 times infinity, infinity times 0, you can change it to the fraction. So as I said before, ln function is going to top, g of x is going to bottom. The ln function is going top, the g of x is going to bottom on by using reciprocal. Next, you have to use L'Hopital's rule. So this is the idea, the L'Hopital's rule, so like this. And calculate. The last step. What's the last step? What's the main problem? You have to eliminate ln. How can you eliminate ln? The main problem is doesn't have ln. How can you eliminate ln from this result? So we have limit this one equal to L. How can you eliminate ln? How can you do that? How can you eliminate ln? Yes, use E. Take E here. Take E, the both sides. So like this. Take E. So limit is going down. So you can interchange E and the limit. So we have it. What happens? Cross out. So we have it. This is the last thing. So step 1, take ln. Step 2, take limit and calculate by using L'Hopital's rule. The last step is take E, right? This is the whole idea for solving this problem. I can give the last example. Limit x value approaching infinity, 1 plus 3 of x to the power x. You can plug infinity into bottom one. And x, what's that? This is the same to 1 plus the 3 over infinity is 0. You plug infinity into x, infinity, exactly 1 to infinity. This is indeterminate form, that's right. You can take ln first. ln 1 plus 3 of x to the power x. So x is down. X is down. Step 2, take limit. Here, you can take limit. So how can you do that? As I said before, ln function is top, x is going to denominator. You can change the fraction. So like this one. ln function, whole ln function is top. The x is going to bottom on by using reciprocal. The next, L'Hopital's rule. Before you take derivative to the top and the bottom on, you have to expand ln of 1 plus 3x is better. ln of 1 plus 3 of x is same to, change it like this, is right? This is same to 1 plus 3 of x is same to x over x plus 3 over x. You can combine x plus 3 over x. You can change it. The next, you can use this rule. ln of x over y is ln of x minus ln of y. So like this. So change it to the difference. Next, take derivative is better. Carbon. What is ln of x prime, x plus 3 prime? ln of x plus 3 prime is exactly same to this one, because this one prime is we have x plus 3 prime over x plus 3. You can use this rule. This is 1 over x plus 3. So we have it. This one. The n of x prime is just 1 over x. The 1 over x prime, we calculate before. This is x to the minus 1 prime. You can use a power rule. The minus 1 times x to the negative 2. You can change it minus 1 times 1 over x squared, the same to negative 1 over x squared. You can change it like this. The next tip. You just only change numerator by only one fraction by using common denominator, like this, is right? So here, how can you find this one? 1 over x plus 3 minus 1 over x things. First one, so we can multiply by x, the first one. Second one, x plus 3 over x plus 3. And combine. Same to x minus 1 times x plus 3. You can use quantity over x times x plus 3. So we have this result here. The next, distribute negative 1. This is same to x minus 3. X is cancelled, only negative 3. The one more times reciprocal of denominator. Combine. Change positive. The 3 times x squared is 3x squared. X squared plus 3x. The next one, x value approaching infinity. Top one is infinity over infinity form. I want to use relative ratio growth. X squared and the x. X is growing faster than x, ignore 3x. So cross out x squared, 3. This is step 2. What is step 3? Step 3 is take E. So take E. Just only take E. Answer is EQ. It's good? So I want to give one good general formula from this one here. So from this example, we have one good result. X value approaching infinity, 1 plus a over x to the power bx. This is exactly 1 to power infinity form. What is the answer? This is always e to the a times b. This is one good formula. I'm going to give one example. Problem is given like this. X value approaching infinity, 1 minus 2 over x, the 3x. What is answer? So by using formula, this formula, what is answer? What do you think? So what is answer of this question? Eta 6. You can change it. Really be careful. This is what? Positive sign. You can change. Limit. X value approaches infinity. You can change 1 plus negative 2 over x. Yes, negative 6. Here, so we have e to the power negative 2 times 3. We have e to the negative 6. We have it. This is one good idea for solving this problem. That's it. This is all for today's lecture. So if you have any question, could you write your question on the chatting board? I will answer your question. If you don't have any question, you can delete this live session. So thank you for attending my classes. I really appreciate it. So any question, let me know. I'm just waiting for your question. Okay, no question. Good. So thank you. You're welcome. Thanks. So see you later.